Okay, great. Okay, hi, my name is Stephen Allwright. I'm the lead data scientist at Elkjøp Nordic, and I'm here to be talking today about predicting customer behavior, a project that we've been working on for the past few months at Elkjøp Nordic. And I wanted to approach it from a business point of view where it's low frequency as opposed to a high frequency business. So the agenda for today is, firstly, I'm going to look at what is Elkjøp, explain a little bit about what we do. And then I'm going to talk about what we can do or what we do at Elkjøp in terms of data science projects. And then I'm going to focus on the project that is the subject of the presentation, which is purchase prediction. And then a little bit about the challenges, learnings, and future development from this project. So, who are Elkjøp Nordic? Elkjøp Nordic is the Nordics' largest electronics retailer. We have 414 stores based in Norway, Sweden, Denmark, and Finland. And we have franchises in Faroe Islands, Iceland, and Greenland. In each of these countries, we go by different names. So in Norway, we're called Elkjøp. In Sweden and Denmark, we are called Elgiganten. And then in Finland, we're called Giganti. And I work as a lead data scientist in a larger insights and analytics department, which consists of a data engineering team, business intelligence team, and us, the data science team. And we as an insights and analytics department serve the whole organization for everything they need from data and insight. So where does the data science happen? So as I said, we work across the organization in Elkjøp. So that means we are creating projects both for internal use, internal workflows, and also external use, directly facing our customers. And these external projects are very exciting to work on because they directly impact our millions of customers across the Nordics. So I'm going now to just give an example of some of the projects that we work on at Elkjøp. So the first one is one of our first projects that we worked on a few years ago, and that is article onboarding. So you as a customer may want to compare attributes of a given product. So say, for example, you're looking at a washing machine and you want to compare two washing machines against each other. And you want to look at the spin speed of one washing machine against another from a different supplier. Well, the problem for us is that we get new products every single day that we need to onboard onto our platform. And the problem is that these suppliers often send different descriptions for their attributes than each other. So meaning that spin speed for one company could be RPM for another. So we created a model that suggests matches for these attributes together. Another example of a project is accessory attachment. Now, this is a key solution for our e-commerce platform because people often want to find accessories that are suitable and match the main product that they're interested in. So we created a model which gives recommendations for accessories that are both suitable and a match. Because, for example, if you were looking at a charger for your MacBook Pro, there may be another charger which is a match, i.e. maybe a USB-C charger for a Windows laptop, but it's not really suitable if you wanted an Apple charger for your MacBook. So as I said, we created a model to suggest this on our e-commerce platform. Another real key area for us is personalization. So this is absolutely key for communication and e-commerce platform. So we create, for example, customer segmentation models, product recommendation, and behavior prediction models that help us adjust our communication to the customers based off of these models. For example, if you've purchased a washing machine recently, you shouldn't really be receiving communication and messaging about washing machines. A very simple example, but that's the kind of thing that we work on as well. And lastly, demand forecasting. This is a very operational type of project for us that helps us better plan and organize within the organization. So we predict demand for example, stores and also for given services in Elkjøp. So footfall into our stores, calls into the call center, for example, and also demand for given services such as collect at store. And these help give an indication of future behavior that helps us plan better. So those are some examples of projects that we work on, but the one that I wanted to focus on today was purchase prediction. This is a very self-explanatory title for a project, but this is something that we've been working on for the past couple of months. And it's part of a wider initiative in the data science team at Elkjøp Nordic to focus on customer experience and the experience that customers have when purchasing with us. And this project tries to answer the following question. Will a customer purchase in the next X number of months? So this is the question, but then we have to scope out the project. We have to scope this out with the end users. So then the first question is, why predict purchases? What is the need? Is it just an interesting area to look into, or does it actually give genuine value? So the first reason as to why is it helps us to forecast demand. If we are able to accurately predict if a customer is going to purchase, then this helps us to better plan and organize different services and maybe purchasing of products for the future. The second is measuring performance. If we're able to track these predictions and these probabilities over time, and we see that the probabilities or the amount of customers who are predicted to purchase increases or decreases, then this could be an indication to performance, for example, for marketing or for our e-commerce platform. And then we can look into subsets of these people. How are different segments of customers performing in terms of their purchase prediction? And then the third is it helps us to personalize the communication. If a customer, for example, has a very high probability of purchasing, then the action required and the effort required from us to entice them to purchase is very low. However, if a customer has a very low probability of purchasing, then this means that we have to entice them with possibly vouchers or enticing offers and campaigns to entice them to purchase. That's the why. That's the why would we do this. But then there's the what. What does it actually need to do? What's the output? What do the end users need to see? The first requirement for the project is that it needs to be a 12-month period. Now, this is mainly due to the fact that consumer electronics is a very yearly based industry. There are very fixed campaigns and events throughout the year that customers know and rely on. For example, Black Friday, Christmas, January sales, back to school, all of these key campaigns that happen throughout the year that people tend to plan purchases around. And so thus the end users need this project to be a 12-month prediction. The second is that it needs to be individually accurate. Now, the reason that I mention this is because this really affects the type of model and the approach that we go for. It doesn't necessarily, because there are some projects or some models that work very well at a very aggregated level for a country, for example, or a town or a city, but they're not very good working at an individual level. So this, as per the end user's needs to be individually accurate as it's being used for personalizing of communication. The third is that it needs to be stable. Now, this is to say that we can't see changes for a given customer that range from 0.2 to 1 to 0.5 to 0.9 without them exhibiting any kind of behavior. So we need the model to be stable, and this changes the frequency at which we train the model. And then the fourth is that it needs to be interpretable. Now, this means that if we see a customer change from 0.1 probability of purchasing to a 0.9, then we need to be able to explain why. Is it because they clicked on a newsletter? Is it because they purchased something? Is it because they've been on the website a lot recently? These need to be explainable, such that business users can then understand how to better entice people to purchase. What is it that really drives purchases? And then the fifth is that it needs to be segmentable. Now, this being a classification problem, 0 or 1, purchase or not, we wanted to make it more granular. So take the probability of purchasing and make multiple segments out of those probabilities such that it's more understandable for end users and it's easier to implement a strategy around those segment names. And I'll come on to that a little bit later. I'm going to explain more about that segmentation later. So that is the why and the what. That's a good project scope. But the problem is that consumer electronics is not a high frequency industry. A lot of examples that you read online about purchase prediction models, or maybe customer lifetime value or revenue prediction, any kind of customer behavior prediction, tends to be focused around high frequency industries, such as groceries or clothes and fashion, or maybe contractual businesses. However, consumer electronics, people tend to purchase a few times a year, maybe 1, 2, or 3 times a year on average. And also the products that people are purchasing are not necessarily leading indicators of future product purchases. So then this begs the question, how do you actually predict for demand when you don't have many leading indicators in the purchases or in the frequency? There's also a few other challenges as well that we experience when creating this model and planning for it. The first one is that I just said that previous product purchases don't indicate future products. If you buy a fridge, that doesn't mean that you're likely to buy a TV next. If you buy a TV, it may mean that you're interested in TV-related accessories, but it doesn't really give an indication as to your next purchase or when you'll purchase. Also, as I was saying, electronics is not a habitual purchase. People aren't purchasing TVs or phones or vacuum cleaners every month. And so purchases tend to be quite clumpy, meaning that big purchases, significant purchases, tend to happen around life events. So maybe you move house, or you have a child, or you change job, all meaning that you maybe need more appliances, more products to fit that change in life. And also then comes a question mainly around when you have brick and mortar stores, whereby not all purchases may be connected up to a customer, because a customer is allowed to walk into a brick and mortar store and purchase without identifying themselves. And so you may have certain purchases that may not appear connected to that customer. So these are the challenges, and they're probably challenges that you may be facing as well if you're in a low frequency industry. So what we did when we first started tackling this problem is we first looked at the kind of industry standard when it comes to purchase prediction and revenue prediction, and that was the buy until you die models. So we tried a Pareto MBD model. However, these worked okay at a country level, and even at a country level, it wasn't highly accurate. But at an individual level, it was wildly off, meaning that it didn't really fulfill any of the requirements of the project in the first place. And also, we felt as if because the Pareto MBD model only really uses revenue, frequency, and recency as a feature, we weren't utilizing all of the data that we have available on our customers, marketing data, clickstream data. And so we felt like we could do a better job if we were able to utilize all of the data that we have in our data warehouse. And so what we ended up landing on was just using a XGBoost classification model built on a quite highly tailored data set from our data warehouse. So what I'm going to focus on mainly is the data set that we used to make this model rather than the model itself, because we found that the largest increases or the most significant increases in accuracy for purchase prediction came from the data rather than the model tuning. So to talk about the solution itself. First, we have our data warehouse, which is hosted in Snowflake. So in Snowflake, we have lots and lots of different data sources connected up from across the business, everything from marketing to call centers to order data. And then we create our training and our scoring data set here. So this data set is mainly consisted of 4 key areas. That is the order history, your standard transactions, what they purchased, where they purchased it, when, and then the website interactions. That's the clickstream data. So what pages have they visited? When did they last visit? How often do they visit? What's the session quality like? And then marketing interactions. So have they interacted with any newsletter or piece of marketing recently? And then demographic data that we also have on our customers as well. And what we do is we use this data set to train and score our models in the cloud, and we use Azure Machine Learning for our cloud here. And when I say country models, the reason why I specify this is because our initial theory was that we would use the data from all 4 countries to create a large model that served all 4 countries, hoping to utilize the large amounts of data so that the model would be able to learn multiple situations. However, what we found is that by training individual models, we achieved a higher level of accuracy for the countries than one singular model. This is probably due to the fact that each country has slightly different purchasing patterns, such that it affects the model significantly. So we train regularly, but it's not on a schedule. We retrain the model when the data shifts significantly from the training data, such that we need to retrain. So we have a data monitoring schedule set up, such that we can see the drift in the data over time. But we score every day. And so what we do is we create this data set, score for the individual customers, and then we send this data back to Snowflake, and we connect these predictions and the groupings to our customer data model. And then that customer data model is then obviously connected up to systems and also the self-service tools that we use, such that these predictions are very easily accessible for end users. And as I say here, the probability segment as well, and I'm going to come on to that probability segment in a little bit. And then once we have these predictions within Snowflake connected to the customer data model, then we're able to display these results in Tableau, in other visualization tools, and also in systems, operational systems that we have, such as the e-commerce system or the marketing system. So that is the overview of the solution itself. And the accuracy of the model, obviously we have 4 models, 1 for each country, is around 0.72 AUC for each of these models. So it gives us a good indication of future behavior. It is not necessarily immensely accurate. It's not over 0.9, for example, but for a low frequency industry, it's a very good level of accuracy and more than we were expecting. So I mentioned about the probability segments multiple times. And what this is that if we were to give business end users just the binary 0, 1, predicted to purchase, yes or no, that gives them a lot of information, but it doesn't give them significant information related to the behavior of the customer. Because within that yes and no, purchase or not, there's different bounds. You could have someone who has a very high probability. So you would call them expected. They're expected to purchase. But then within that bound, there's also people who are 0.51, people who are likely to purchase, but may need some action to push them to purchase. This could be an offer, it could be a voucher, it could be anything. And then also you have people who are dormant, very at the bottom end, people who you'll need to put a lot of action in to wake them up, to activate them to purchase. And the words that we use to describe these segments also helps with the communication with end users, because immediately you say to someone, this person is in the expected group, then people know what that means. And also equally, if you say they're in the dormant group, people know what that means instinctively. So this helps us work closer with the end users, and that is the segmentation that we use. And as a team, as a data science team in Elkjøp, we very much focus on getting projects out there quickly and then iterating over them with end users. So not trying to spend loads of time creating the perfect model and then putting it out there, but putting out a good solution, seeing if it's useful, and then developing further. And so there's certain areas that we want to add into the model. One of them, for example, is adding embeddings for both the products that people purchase and the logs. So clickstream data and the marketing logs as well. So what are they looking at? What are the pages? What products have they purchased? What category is that product in? And then helping possibly to indicate what type of customer they are. And also wanting to fill the interaction gaps. So we haven't fully yet added every single customer interaction into the model because there's a lot of different interactions. And so we want to add, for example, people's experience with delivery and their experience with customer service into the model, because we believe that those are indicators as to how satisfied a customer is with their service. And then we also wanted to look at shorter time periods as well. So obviously at the moment we're looking at 12 months. We wanted to see if we could shrink that down to maybe looking at the next month or next week. And then taking a step further as well. So instead of just looking at if they will purchase or not, looking at what's the value of the purchases and the number of purchases that is predicted. So that's the future development. And then I want to finish by giving some advice on people who are maybe watching this now, who are wanting to implement some form of purchase prediction or behavior prediction, but work within a low frequency environment such as us. So there's three key areas that I wanted to point out in terms of advice. The first one is that order data is not enough. If you're in a high frequency industry, order data is probably enough to indicate some form of habitual behavior. If you, for example, are in a grocery business and someone is purchasing bread every week, that is enough to give a good indication that they will purchase bread next week. However, in the industry such as us, with low frequency, this is not enough. And what you really need is you need interaction data as well, in addition to the order data. So marketing, e-commerce experience, these kind of things that really give an indication as to future behavior. The second is more of a feature engineering piece of advice, and that is that when you're working with large scoring periods, such as a year like we do, then we really need to look at scaling the time-based features. So for example, if you have a feature such as days since first purchase or days since membership, then when you go into the scoring period, this particular feature is extremely long and it's a lot longer than the model would have seen before. So we need to make sure that we're scaling these features. Not such a problem if you're working with a shorter period, but for us, it was something that was significant. And then the third piece of advice is weigh up the effort versus the value. If you don't have interaction data and you only have transactions, then this may not be worth the effort, because the value of it may just be that you're able to achieve maybe a 0.6 AUC, and that is not necessarily as valuable for the amount of effort that would take to create this. And it may be worth better trying to understand the behavior of the customers in terms of segmentation and really trying to understand who the customer is before we try to predict future behavior. So that's my the project. That's the talk that I wanted to give. Obviously now going to open up for questions. I see there's a few questions in the chat. But yeah, I just wanted to say thank you for listening. Thanks for coming to the talk. And another note is just that we are hiring at the moment for a data scientist to join the team. So if you're interested in working with consumer and customer-based projects at a large scale that affect people across the Nordics, then get in touch. I'd love to hear from you. So I see there's a few questions. Okay. Could you please elaborate on how you monitor data drift? Do you use Azure ML for that too? That's a really good question. Yep, so we use Azure ML for measuring the data drift. So in Azure ML, you register the data set that you train the model on. And I think it's called the base data set or the base data set, yeah. And then you register then each scoring data set that you use for the predictions. And then you can set up a scheduler that then measures the drift in each of the features in that data set. And then you can set up like an alert system whereby if it drifts by more than 20%, then it will alert you. And then you can also set up automatic retraining as well if you want. So that is something that's built into Azure ML. I assume that it's also built into GCP and AWS as well if you use them. Okay, how smooth is the process of building training sets in Snowflake, but doing the model and scoring in Azure? Yeah, that's also a very good question. So for us, it's very simple. There's a good Python connector in Snowflake. So it's very easy to connect to Snowflake and pull the data there into Azure ML. We actually have also developed, and this is actually a good piece of advice for data science teams. We created an internal Python package that handled a lot of like boilerplate code that we use for our infrastructure. So in this exact example, reading data from Snowflake, there's a lot of code that you would just write on as boilerplate that just allows you to read, such as sign in, what's the user using, what database you're looking at. But that is very, very simple to do. And so what we end up doing mostly is we do a lot of the feature engineering in Snowflake in SQL, and then we create either a table or a view, and then we just read from that table or view into Azure ML. So we're not using compute in Azure ML to process the data set initially. There's another question here. Could you give some more details on the data? Oh, I've already answered that. Data drift modeling, which tools you use? Yeah, I believe that is, okay, it's a different person, but the same question. So yeah, we use Azure ML for data drift monitoring. I assume there's lots of different tools out there available as well. And then, yeah, could you give an example of what a scaled time feature could be? Yeah, so say, for example, you have days since first purchase as an example. So me as a customer purchased for the first time 365 days ago. Then if in the scoring period, then that may be 365 times 2, right? So what we end up doing is we take days since first purchase and then divide it by, maybe, for example, you divide it by the number of orders. So you could say, first purchase is 365 days ago, I've had 2 purchases. So then you say 182 and a half or whatever is a scaled purchase. So most of the time we scale it by using either number of purchases or by using the actual number of days since first purchase itself. So it's not like a min-max scaling thing. We scale it with another feature. How often do you do model retraining? Do you do any A/B testing on different model versions? Good question. So we do model retraining based on the data drift. So this could be, we could retrain it maybe once a month or once every quarter, whenever the data drifts significantly away from the base data set. So it's not on a fixed schedule. And then do you do any A/B testing on different model versions? We don't do A/B testing on different model versions yet, but we do a lot of A/B testing on the effects of the model itself. So we look at people or tailor some communication to the model, and then see if that tailored communication, if people who receive that tailored communication act differently to people who receive some kind of control. And then here's another question, how is the prediction used for personalization if it's a general purchase prediction versus an item specific prediction? Yeah, so the first answer to that question is that it's used for personalization in understanding what type of messaging we send to someone. So if you are someone who has a very high probability of purchasing an output directly from the model, then we don't really need to send you any vouchers or offers. Whereas if you have a very low probability of purchasing, then we'll send you maybe some offers or some kind of good campaign. So this particular model is looking at the type of messaging and understanding what type of person you are. Whereas what you were saying here versus an item specific prediction, then that would be, for example, one of our product recommender models. That then affects directly the content of the messaging. So say, for example, if you receive a newsletter from us, then the content of that email would be based off of the product recommender model, and that is an item specific. So there's two different models that we use for this. I believe, I don't see any other questions. Yeah, I think that's it. Yeah, so thank you very much for listening. Unless you want to send a question now, I think we probably have I think we're over time slightly, but if you've got a question, you can just put it in. But otherwise, thank you for listening. And okay, here's one more. This is a good question. Do you have a platform that supports MLOps approach, CI/CD, reproducibility, and monitoring? So we use Azure DevOps for a lot of the MLOps that we do. So we have a lot of CI/CD pipelines that if we make a change in a model, say for example for this model, if we make a change to the feature engineering or any code change, then you push the code to master branch, and then that master branch then fires off a pipeline which then implements that change into the production model. So we do a lot of MLOps. It's mainly based around using DevOps as a hub for that. Okay, are there any other questions that anyone has? Also, another just quick point on the MLOps is that's having DevOps has been a big plus for us, using DevOps to implement an MLOps process, because it makes it a lot easier for other data scientists to then come and look at your code and understand what you're doing. Because we use a lot of, as I said, we use a Python package that we developed internally to replace boilerplate code. So it's very easy to go from project to project to understand what people are doing. So that's a big benefit. Okay, right. Well, I guess that's that. I want to say thanks for listening. And as I said, we are hiring. So if you want to get in touch, then reach out on LinkedIn and send me a message. So thank you very much and have a good rest of the conference. Thanks a lot. Bye.